Some integrals require more work and different method than the ones we've seen in section 5.1. So we're going to use a method called substitution. And here's the strategy for it. So we look at our expression that we want to integrate, and here's what we're going to do. We look to see if we have a quotient, an exponential, or a power, or a radical. Now, if we have a quotient, we're going to let u equal the denominator. Exponential, u will be the exponent, and a radical or a power, u be the base. So here's a couple of quick examples, and then we'll do more that are actually in the problem set. In this first integral, notice that we've got a quotient, so I'm going to take a look at this first suggestion up here. If you have a quotient, I'm going to let u equal the denominator. So the denominator here is at 2x cubed plus 5x. So what I'm going to do here is let u equal 2x cubed plus 5x. So I'm giving this denominator another name for the time being. I'm going to call it u. Now, if I do that, here's where we are so far in the process. I'm going to have this. I'm going to have 6x plus 5 over u dx. So I've got this thing partially converted to u, but what we still need to get here is this 6x plus 5 dx. I need to get that converted to u. So if this method is going to work, here's what should happen. From this u right here, take du dx. So if I take du dx, I'm going to get 6x plus 5. Now maybe you recognize there's that 6x plus 5 in the numerator, but I want 6x plus 5 dx. So back here, multiply both sides by dx, and we'll get this. We'll get du is equal to the quantity 6x plus 5 dx. So now we've got u in the denominator and the 6x plus 5 dx right here. Well, that's just du. So when I rewrite this integral, I'm going to write it like this. I'll do it up at the top here. This will be the integral. I'll write it 1 over u, and what remains, right here's what remains, 6x plus 5 dx, right over here, that's just du. So now I can write this as du. And now I've got an integral that I recognize, right? I know what we typically deal with 1 over x, but I'm just changing the name now to 1 over u. So this I know comes from the natural log of the absolute value of u plus c. But now I know what u is. U was way back over here. You know, when you do these, you might just want to circle that so that you can find it easily enough. And then I'm going to take that value, that expression for u, and put it right back in here. So here's what I'll have. I'll have the natural log of the absolute value of 2x cubed plus 5x plus c. Now in the second example, we have an exponential. That'll be this one right here. So the idea is, the suggestion is to let u equal the exponent. And the exponent here is 5x. So the suggestion is to try this. So let u equal 5x. Now I learned to circle that so we can find it later. So what we've got so far with that substitution is going to be this. The integral of 45 e to the u dx. So if this method is going to work, we need to get that dx, and the dx should come from right back up in here. We should be able to get it from this. So back up here in u, let's take du dx. So du dx is equal to 5. Multiply both sides by dx. So we'll get du is equal to 5 dx. All right, so we've made some progress, but what we're looking for is 45 dx, not just 5 dx, right? We want to get 45 dx, not just 5 dx. But we can get a 45 if we multiply this side by 9, but then we have to multiply both sides by 9. So let's multiply by 9, and that'll give us that 9 du is 45 dx. Now look what we have. This 45 dx that I needed here, 45 dx, that's 9 du. So now I'll make that substitution. I've got e to the u already, so I'm going to write that. So I'll do it up here. So I'm going to have e to the u, and then what's left? What's left is that 45 dx, but that 45 dx is 9 du. So this is just times 9 du. I'll take the 9 out. It's a constant. So remember, when you differentiate or integrate, the constant comes along. E to the u du. And we recognize this. The integral of e to the x dx is just e to the x, but we have u, so we'll call this 9 e to the u plus c. And one more step, right? One more step. Replace that u with what we did in the beginning, 5x. So I'll resubstitute. I'll call it 9e to the 5x plus c. Let's do a last example that will give us an idea of how to use this one here. So suppose we have a power or a radical. Now, I've written this as a power, right? We've got something to a power. So when you have a power, the suggestion is to let u equal the base of that power. So what we're going to do here is we're going to let u equal the base, 15x squared minus 4. I'll circle that. So here's what we have so far. Making that substitution, we'll have the integral of 10x and then times u to the 6th dx. So we're partway there. What we need to do is we need to get this 10x dx in terms of u. Now, if the method's going to work, we should be able to get it from this right here. So let's give that a try. Let's find du dx. So du dx is equal to, looks like 30x multiplied by that dx. So we'll get du is equal to 30x dx. So we're close, right? We have 30x dx, but what we want is 10x dx. So we got 3 times too much. I want a 10 over here. What if we divide by 3? So if we divide by 3, I'm going to make it look like this. This will be 1/3 du, right? Du over 3 is the same as 1/3 du equals, but if I divide 30 by 3, I get 10x dx, and there it is. That's what I'm looking for. There's that 10x dx. That turns out to be 1/3 du. So now if I make the rest of that substitution, right, I'm going to put that in here. So making the rest of that substitution, we'll get this. I'll start with the u to the 6th times all that stuff that was left. Now what was left was 10x dx. Our little analysis here showed that 10x dx is 1/3 du. So this is going to be 1/3 du. Take the 1/3 out. 1/3 integral of u to the 6th du. And we know what to do here. This is just a power. So I'm going to get 1/3 times, all right, u to the 7 over to 7 plus c. And now I think I'm going to write this as 1 over 21 u to the 7th plus c. And now what I'm going to do is I'm going to go get that u from the very beginning. So what did we have? What was u? U, I circled it so I could find it. 15x squared plus minus 4. So we're going to have 1 over 21 times the quantity, 15x squared minus 4 to the 7th plus c.